In this video, I'll be working through the question you see on the screen here from 2025 Leaving Cert Higher Level Maths Paper 1. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the videos if you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. Question 2 starts off with a relatively straightforward question. They give us this weird looking function. It's very difficult to draw. We don't have to, thankfully. Fx is equal to 6 plus x squared plus sine 4x. And they simply ask us to find the derivative of that. Now the derivative is a great function in that it doesn't worry about adding. So these are 3 different questions for the derivative. So if I want to know the derivative, I can just do each of these 3 parts separately. The derivative of 6, it's a constant, it's 0. There's nothing there. The derivative of x squared is just 2x. Now differentiating sine 4x is a little more difficult. You do have to use the chain rule, but I'm going to assume most students can do that on their own. If you can't, look up differentiation, look up differentiating trigonomic functions, look up the chain rule. You need to be able to get good at these ones that you can just do it on the fly, as it were. To slow it down a little, the derivative of sine is cosine. The problem is what's inside here is a little too complex. So the derivative of this is cosine 4x, but then we have to deal with what's inside here being complex. So you need to differentiate that again, is how it sort of works out. And the derivative of this is 4. Multiply that by 4. Okay, that's the answer to A part 1. In part 2, they ask us to find the equation to the curve of this curve up here at the point 0. Give your answer in certain forms. Okay, when they're asking to find the tangent, tangent is a straight line, the equation of a tangent. We're looking for the equation of a line. You should be thinking you're looking for a point and a slope. Okay, so we're looking for a point on this. They told us part of the point is 0. So we're looking for that point at x equals 0. And we're looking for the slope, m equals. Now, when you think slope, you should think differentiation. And they told us the point. So really, the slope is equal to the derivative at 0, or the derivative at 0. We can just fill that in. We can get that right now. 2 times 0 is 0. 4 times 0 is 0. Cosine of 0 is 1. So 4 times 1, this all just comes out as 4. Put it in your calculator. Let me go through that again. 2 times 0 is 0. It's gone. 4 times what turns out to be 1 is 4. The slope is 4. All we're now looking for is this point. And again, they give you the hint there, y is equal to fx, just in case you weren't sure. The y point is just f0, because y and fx are sort of the same thing. So f0 is equal to 6 plus 0. Sine of 0 is another 0. This is equal to 6. So really the second part of A boils down to find the equation of this line here. So however you do equations of lines, there's a couple of ways. Well, do it however you want. You should be able to do the equation of a line. I tend to do it this way. Y is equal to mx plus c. I need to know what c is. I know what m is. I need to know what c is, so I'll fill in all the numbers I have. 6 is equal to 4 times 0 plus c. C is equal to 6. Write it all again. Y is equal to 4x plus 6. And that's the equation of a line. It's not how they wanted it. They wanted it in the form of ax plus by plus c. So I just rearranged this. Leave 4x where it is. Bring the y over, minus y. And leave the 6 where it is. Change the equals, I guess, to this side. And that's how they wanted it. A would be a 4, B would be a minus 1, and C would be a 6 in their format. Okay, that's it for part A. Let me clean this off and we'll do B. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, part B is both easy and difficult. It's easy if you know how to do it and quick if you know how to do it. But if you don't know how to do it, it can be difficult to get marks. So I'm going to take my time explaining everything. In an exam, if you're faced with a question like this where I don't really know what I'm doing, like the more study you do, the more likely you will find some of these little marks, even if you don't get full marks. Okay, with that said, they draw us a picture, looks roughly like this, a 4 on the x-axis, 4 on the y, and they ask you to state the range of values for x for which the derivative of g, this line here is a function gx, let's put in gx here, and in part 1, B part 1, they're talking about the derivative of x. There's no function to get the derivative of, but they're talking about the derivative of x being bigger than 2. They need you to understand that derivatives are the slopes of the tangent to a curve. In this case, it's a curve. A straight line is a curve. The tangent to this line is the line itself. So what they're asking is, what's the gradient? What's the slope of this line and the slope of this line, because that is the derivative. To find the gradient from a picture like this, I tend to think of it as triangles. This bottom one here, I'll redraw it so not to ruin my picture. This bottom one, it's 3 long and it's 1 high. The slope is just the rise over the run, the height over the base. In this case, it's 1/3. You just need to be a little careful you get the sign right. Going up is positive. Going down is negative. So the slope of this one is 1/3. The bigger one, I'm starting from here and coming up. What height is this? It's not 4 high. From the base of this other point is 3. So it's 3 high and it's 1 across. From here to here is 1, and the slope of this one, let's put in m. M is equal to 3. So when they ask you when is the gradient bigger than 2, the answer to this question is when x is bigger than 3. Or let's actually write that as x is bigger than 3 and less than 4. Yeah, that's when let me write like this: the derivative is equal to 3 in this world, and it's equal to 1/3 when x is bigger than 0 and less than 3. An interesting question here is, what happens when it equals 3, or when it equals 4, or when it equals 0? Because it's just a picture we have, it's undefined, we don't know. You can't have a tangent around this curve or around this point, like what could it be? It doesn't continue on. But anyway, that's for another day. In part 2, they give us this weird looking thing, g of 3. Give your answer in the form of a/b. So what is this? It is difficult, is what it is. I don't know what this is, but something I do understand is g of x. I know what g of 3 is equal to. I can just look at this picture and go, there's 3. If I put 3 in, I get 1 out. G of 3 is equal to 1. So instead of writing this mess, I could just rewrite it as, instead of g of 3, it's equal to 1, I'll write 1 in. So this is the same as this. These are equal. What's g of 1? We go to our graph of 1, and what comes out? What number is here? You can probably guess it's 1/3. Let's think of that a little more clearly. This is a 1, 2 and 3 from this triangle. I don't want to ruin my picture here. It's a straight line. It goes between 0 and 3. Between 0 and 3 it goes between 0 and 1. It must go up a third each time. It's 1 over 3 is the answer there. Okay, for part 3, I think they panicked in part 3. They gave you a question, and then probably the teachers who made the questions argued and said, oh, that's too hard, let's give them a hint. Because in this question they give us this drawing again, and they ask you to draw the graph of the inverse, g, the inverse of this function. And they probably could have just done that and asked you to draw it, but they did a bit more. They gave you a hint. The hint really gives you the whole answer if you understand the hint, which I understand a lot of you won't. The hint is the graph of the inverse is the image of the graph under axial symmetry of the line y is equal to x. Now, what does that mean? Let me answer the question using the hint first, because when I see the question, draw the inverse, I think of the hint. Like, I know the hint, you are expected to know that hint. So they gave it to you, that was nice of them, but you are expected to know that hint they gave you, that it's an image through this line. So this line, y is equal to x, what does that look like? Y is 0 equals 0, 1 equals 1, 2 equals 2, 3 equals 3, 4 equals 4. This is a straight line. This is what y equals x looks like. Y equals x looks like a straight line there. To get the inverse of a function, it's just the image through this, and that means if you were to hold this line up and fold everything through it, let's see, fold everything across, 0 would go to 0, the 4 would go to the 4. They're both on the line. This guy here would fold through the line. This 3 would go to this 3. This 1 would go to this 1. So my drawing's not the best. It should be at 3, 1 here. Let me redo this dotted line. There we go. And you get this mirror image. This mirror image like that. That's and that's it. That's the full marks. I'll just explain that a little more in a different drawing. Imagine we had a drawing that looked a bit different. A function that looked like that, and we still had the y equals x line through here. This would still, the inverse of this is still a mirror. It would everything would go through it, and it would look something more like this. My drawing's not the best there, but it would be this mirror image through the line. Okay, that's it for question 2. If you have any questions, please put them in the comments below. Do put in the timestamp from where the question is to help me answer. Thanks for watching and have a great day.